Hello students, in this video we'll see an example of classifying a quadric surface. Let's classify the quadric surface z squared plus 4x squared minus 4xy plus 6y squared is equal to 1. Now, classifying this quadric surface would be easy if there was no negative 4xy in this. If we had z squared plus 4x squared plus 6y squared equals equal to 1, that would be an ellipsoid. However, this xy term throws things off a little bit. Let's look at the cross sections. So if, for example, if the x variable was equal to 0, and we're in the yz plane, if x was equal to 0, this is going to reduce to what? This will reduce to z squared plus 6y squared is equal to 1. And so these cross sections are ellipses. So one of the cross sections are ellipses. Let's see what happens if y is equal to 0. If y is equal to 0, then what happens? If y is equal to 0, then this is going to turn into z squared plus 4x squared is equal to 1. And these are also the equations of ellipses. And finally, we have to figure out the last cross section to sort of get a good sense of what the quadric surface is doing. So if, for example, z was equal to 0, then we have this conic section. Then we'll have 4x squared minus 4xy plus 6y squared is equal to 1. And we want to classify this conic section. So our goal now is to classify this conic. Let's classify the conic section. And to do this, what we do is we're going to form the corresponding quadratic form matrix. So the quadratic form matrix that corresponds to this conic is 4. Then half of negative 4 is going to be a negative 2, a negative 2, and then a 6. And our goal now is to find the eigenvalues of this equation. Find the eigenvalues. So let's find the eigenvalues of this equation. So let's do so. So we're going to have what? We're going to have a determinant of 4 minus lambda, and then a negative 2, and then a negative 2, and then a 6 minus lambda is equal to 0. So doing this determinant, I'm going to have a lambda minus 6, a lambda minus 4, and then minus minus minus. So 3 minus is 2 is a negative 4 is equal to 0. And so we'll have a lambda squared minus 10 lambda, then a positive 24. Positive 24 minus 4 is going to be a plus 20 is equal to 0. And so what we have over here, so we're going to have lambda is equal to 10 plus or minus the square root of what? The square root of 100, that's 10 squared, minus 4 times 20, so that's going to be 4 times 20, which is going to be 80, all divided by 2. So the eigenvalues over here are going to be 10 plus or minus, that's going to be 80, so 20. So 20 is the same as 2 root 5. So I have 2 square root 5, all divided by 2. So this is going to be what? This is going to be 5 plus or minus the square root of 5. Now 5 plus root 5 is positive, and 5 minus root 5 are positive. Both these eigenvalues are positive. When you have two positive eigenvalues for the corresponding quadratic form, that tells you that these cross sections are actually going to be ellipses. So I have cross sections which are all ellipses. That allows us to conclude that this quadric surface is an ellipsoid. So our quadric surface over here is an ellipsoid. And ellipsoids have the shape that look like this, right? Every cross section is going to be an ellipse. Now, the one thing we haven't been able to figure out yet, which we can figure out using linear algebra, is how much this ellipse is rotating with respect to the xy plane, how much is rotating with the yz plane and the xz plane. And that's where this negative 4xy term comes into play. That is going to take this ellipse, which is centered at the origin, and it's going to rotate it about an axis and put it into a new configuration. So that's called solving the principal axis problem, which you'll do in your linear algebra course. Thank you very much.